In today's video, we're going to have a look at some of the basic arithmetic operations in MIPS. As you can see here, I've got a couple of values that I've loaded into memory. If you watched the week 1 videos, you'll know that I said these values A, B, and C are similar to what we would think of as variables in Java. But that's not quite the case, because in assembly coding we don't actually have access to variables, we only have registers. So what we mean when we say A is a word and it has the value 10, what we really mean is we're storing the value 10 at memory address A. So if you did have some sort of variable, it's being stored at the memory address. So it's not an actual variable, it's a little bit of memory that we've allocated to have that value. So you can see here I've got A, B, and C. The values that I've given them are arbitrary, you don't really need to care about the specific values. I've given them the type words, as we saw earlier. That's how MIPS holds values, it holds them as words. We use 32-bit format, and these can also represent integers. Okay, so what are we going to do in this video? Well, we're going to figure out how to carry out that calculation using the arithmetic operations that we have in MIPS. So, before we get started, we should have a look at our MIPS summary sheet, and here I've zoomed in on some of the arithmetic operations we have. We have our basic adds, we have add immediate, we have add immediate unsigned. I wouldn't really worried about the unsigned at the moment, though it is interesting. It's not what you would expect it to be, so it might be worth looking into. We also have divide, when multiply, negation, subtract, that sort of stuff. So we'll use these to carry out the equation we have on the page here. But first, as always, I need to load my values from data into registers. So let's start off with loading A into T0, and that should be familiar to all of you. This is just saying that T0 is equal to the value stored at A. And we'll do the same for the other two. Again, I'm just going to use the temporary value registers. You're free to use whichever registers you prefer. At the moment, there's not really a tremendous worry about them. Later on, we will need to think more in depth about where we're going to store our values. But at the moment, we don't need to worry. And finally, we will put C into T2. So this should be familiar to all of you. We encountered the load word operation that just stores a word at a register. Later on this week we'll be having a look at more of the load operations and seeing what they actually do and the nitty-gritty of how they work. But now that we've got them, we can start carrying out this calculation. So because this has a running total, I'm going to store the values in A0 and then print from there. We saw how to print last week, but we'll go over that again quickly. So let's start by carrying out A times B. So I'll use the multiply, and as I say, I'm going to store that in A0 so that we can print it out easily later on. And we'll do T0 and T1. Oh, if I could type anyway, we might do that. Now, this is saying that the register A0 is going to be equal to the multiplication, or the result of the multiplication, of A times B. Oh, actually, we should use lowercase there because we're using the values at the registers, not the actual register addresses themselves. So that's the first part of the calculation. Now we need to do 2C. We need to figure out how to get that. So what I'm going to use instead of multiplying is I'm going to use add, and I'm going to store it in the same address as TC, or as C. So this might look a little bit funny because we're going to use the same operand 3 times. But that's really just saying that in the register that stores C, I want you to now store C plus C. And this is just so that I can save a little bit of space without having to worry about overwriting anything or anything like that. So this is just saying that T2 is now equal to 2C, or C plus C if you prefer. Okay, so that's most of the way through the calculation. And now we just need to subtract 2C from the value stored at A0. Because these are simple arithmetic operations, we're not using multiplication at this point. We can do the addition and subtraction in either order and it won't affect the outcome of the calculation. So I'm going to say in A0, because this is where we're storing a running total, and in here I want to do A0 because we're using the value that's stored there, and T2. Now what that's saying is that A0, our running total register, is now going to be equal to the current total minus 2C. And now we just have to do the last part, but if you remember from the first week's videos, we have the add immediate function, which is what we're going to use to add 10 on at the end here. And we're going to use A0 again because we want to update the total that's stored at A0, and we're going to add 10 to that. And that just says that A0 equals A0 plus 10. Okay, so that's the actual calculation carried out, but because I've stored this at A0, what this allows me to do is load the immediate value into V0 of 1 and perform a system call. And if you'll remember from last week, what this does is it tells the hardware that we need to do a system function, and 1 is the equivalent of printing the integer stored at A0. And the system call just executes that. So that should be everything. Let's save, compile, and have a little look at our code. Now, as you can see in here, we actually can see where we've stored our variables in this register here. We've got A here, which is of course the hexadecimal equivalent of 10. So that will be the value A. And then at +4, what that means is 4 registers on. As remember, every register stores a byte, so 4 bytes on is 1 word along. It stores F, which is 15, which was our value for B, and then we have 14 here, which was our value for C. And of course we have our assemble code. If we run this and execute this, we should get our answer out. There we go. That bit at the top is just because I was fiddling around with this earlier. But there we are. That's everything that we needed to do today. You can also have a look at your registers over here and see the values that we've carried out have been stored in the temporary registers, and our value at A0 has been correctly incremented as we've gone along. So that's everything for today's video. In the next video we'll be having a more in-depth look at the load instructions. I'll see you then.